Okay, so we're going to look at proving these triangles congruent. So we are going to first look at the side theorem to prove triangles congruent. Remember, we have to have 3 sets of corresponding angles, 3 sets of sides to prove 2 triangles congruent. That is the formal definition. But the other day we talked about 5 different theorems or conjectures that will prove triangles congruent with less than those 6 things. So the first one was side. So if I know that AB is congruent to side DE, and then also I know that side BC is congruent to side EF, and then the last set of sides AC is congruent here to DF. If I know that there's 3 sets of corresponding sides that are congruent, then I can prove that triangle ABC is congruent to triangle DEF. I know that. So we're going to use this in proving some of these proofs. So the first one, these are very similar to the ones we've been doing. So we always start with the given information. I am given that PQ is congruent to side ST. Okay, here in my proof, that is written, and that is a piece of given. Well, as you're going through this, you need to mark your picture. If you mark the things on your picture, it'll be a lot easier for you to see what's going on at the very end. So I'm going to mark PQ and ST congruent with 1 tick mark. I am also given that QR is congruent to RT. Again, that's in my given information. So again, that is given. I'm going to put that in my picture. QR is congruent to RT. It's getting 2 tick marks because it's the second set of sides. Also given, R is the midpoint of PS. So R is right here in the middle. So the definition of a midpoint is it's the point in the middle, so it cuts that line segment into 2 equal parts. Again, this was given because it was in that given information. And I do know if this is the midpoint, that means that PR has to be the same as RS. And I can mark that with 3 tick marks. Here again in the statements, that's what I just said. PR is congruent to RS. Now the reason, if you flip to the front of this packet, there were 3 reasons that a set of sides could be congruent. Those 3 reasons were it was given. Well, PR equals RS was not given. It could be the definition of a midpoint, or it could be because of the reflexive property, which means that the same thing is on both sides of that congruent. Well, it's not the reflexive property. It has to be the definition of a midpoint. We talked about that earlier. If R is the midpoint, those segments are congruent. That was the definition of midpoint. And then now lastly, in order to say that my 2 triangles are congruent, I have to say which of the 5 conjectures that we've talked about. So if you look at your picture, this shows a set of sides, and the third set of sides. So these 2 triangles are congruent by side. Okay, let's look at the next one. Looking at now number 2, again, we are going to start with what is given. JL is congruent to MN. Again, that's a piece of given information. And before I move on, I'm going to mark it. JL and MN are congruent. Next piece, K is the midpoint of JN, which is this whole line, and it's also the midpoint of LM, this whole line. So that means K is the midpoint. Again, that is the piece of given information. Now I'm going to use that. If K is the midpoint of JN, that means it divides it in half. That means JK has to be congruent to NK. Okay. If I'm going from that K is the midpoint to 2 things being congruent, that's because of the definition of midpoint. It was one of the 3 things on the front page. Then K was also the midpoint of line LM, which means that LK and KM have to be congruent. That's what the statement is. And again, since K was the midpoint of that line, it is still, again, the definition of midpoint. And then you have enough information to prove these congruent. The last thing we can do is now look. I'm trying to prove that these two triangles are congruent, so I'm going to use one of my 5 conjectures. So if you look up here, I have a set of sides, a second set, and a third set of sides. So these two triangles are congruent by side, side, side. Okay, I want you to pause the video, and I want you to take a few minutes, and you try number 3. Okay, now let's look at side angle side. Okay, again, in order to use side angle side, you have to have 2 sides and the angle, the included angle, the angle right in between them. So if we look at this picture, my one set of sides would be side AB would be congruent to side DE. My angle, that has to be the next thing, would be angle B is congruent to angle E. And then I need a side right beside that, so it would be side BC is congruent to side EF. And if I have side angle side, I can now prove that triangle ABC is congruent to triangle DEF. That's enough information. So let's look at a proof using side angle side. Again, JM is congruent to NL. That's my given information. And just like before, I need to mark that, JM and NL, because it's going to help me see in my picture when I get down to the N. Angle JMN is congruent to angle LNM. Again, that was in my given information. I'm going to mark it. JMN is this angle, and LNM is this angle. And then MN is congruent to MN. Now, that means this side is congruent to itself because it's in both of those triangles. If I were to take this triangle and move it over to where I have 2 triangles that aren't touching, this MN would be in both of those triangles. So it's congruent to itself. Now, when something's congruent to itself, the same thing's on both sides of the congruent side. Just like a mirror, that is the reflexive property. And then lastly, there is enough information to prove these two triangles congruent by having a side, an angle, and a side. And again, that angle is right in between those two sides. It's touching both of those sides. So I can prove this congruent by side, angle, side. Okay, looking at number 5. Okay, first of all, in number 5, we are going to start with the given. AB is congruent to BC. Again, that is given. I'm going to mark it. AB and BC are congruent. We are given that BD bisects angle ABC. Again, that's given. Well, if a length or a side bisects an angle, that means it cuts it into 2 congruent angles. So here's angle ABC, so that means this small angle is congruent to that small angle. But that was given information. Therefore, angle ABD is congruent to angle CBD. Those are those 2 small angles I just marked by the definition of an angle bisector. And this is on that front page. If 2 angles are congruent, there's several reasons, and one of them was an angle bisector. Again, it says that it bisects the angle, so those 2 angles are congruent. That was that definition we learned several weeks ago. We do know that BD is congruent to BD. That side, again, if you split these 2 triangles up, that BD side would be in both of them. So it's congruent to itself because it's in both of those triangles. Again, that is the reflexive property. Therefore, I do have enough information here now to prove these 2 triangles congruent, and I can prove it by side, angle, side. So therefore, that is my reason. Okay, you take just a few minutes and you try 6 and 7 now on your own, and then you will be finished.